Hello, I am Avanti. The question is, in a quadrilateral ABCD, AB is equal to AD, the angle bisectors of angle BAC and angle DAC meet BC and DC at E and F respectively. If BD is equal to 5 units, EF is equal to 3 units and area of triangle BDC is equal to 100 square units, then the area of triangle CEF is. Now before we start the solution, we have to draw the diagram. Let's see how the figure is. This is a required quadrilateral ABCD in which AD is equal to AB. Now join AC. Also it is given that AE is the angle bisector of angle BAC and AF is the angle bisector of angle DAC. Join E and F and B and D. In this question, we use the concept of angle bisector theorem. Let us consider triangle ADC. Since AF is the bisector, of angle BAC, therefore by using the angle bisector theorem, we get AD upon AC is equal to DF upon FC. Call it equation number 1. Now, in triangle ABC, AE bisects angle BAC. Therefore, by using the angle bisector theorem, we have AB upon AC is equal to BE upon EC. Call this equation number 2. Since AD is equal to AB as given in the question, comparing the above two equations, we can write AD upon AC is equal to BE upon EC. Call this equation number 3. Now from 1 and 3 we get DF upon FC is equal to BE upon EC. This implies that DB is parallel to EF and now taking triangles BCD and triangle ECF, we have angle BCD is equal to angle ECF since both are common, and angle CBD is equal to angle CEF since they are the corresponding angles of the parallel lines EF and BD. Therefore, by AA property, we get that triangle CBD is similar to triangle CEF. Also, we know that in similar triangles, area of triangle CBD upon area of triangle CEF is equal to the square of ratio of corresponding side. That means area of triangle BCD upon area of triangle ECF is equal to BD upon EF whole square. Now, in the question, we have been given that area of triangle CBD is equal to 100 square units, BD is equal to 5 units, and EF is equal to 3 units. Now put the required values in the above equation. We get 100 upon area of triangle CEF is equal to 5 upon 3 whole square, that is equal to 25 by 9. This implies area of triangle CEF is equal to 100 into 9 upon 25. On solving, we get area of triangle CEF is equal to 36 square units. This is our required answer, which is option number 3. Thank you. Hello, I am Avanti. The question is, in the adjacent figure, AD is parallel to GF and AF is parallel to ED. The value of X and Y is. Now before we start solving the problem, we need to do a simple construction. Produce DE to meet FG at H. Now, since DH is parallel to AF and AD is parallel to FH, therefore DAFH is a parallelogram. Therefore, angle D is equal to angle F is equal to 95 degree, since opposite angles of a parallelogram are equal. Now, DE is parallel to AF and AD is the transversal. Therefore, angle D plus angle DAF is equal to 180 degree, since internal angle on the same side of a transversal are supplementary. This implies 95 degree plus angle DAF is equal to 180 degree. This implies angle DAF is equal to 85 degree. Now, angle DAF is equal to angle BAC is equal to 85 degree, since they are vertically opposite angles. Now, consider triangle ABC. We have angle A plus angle B plus angle C is equal to 180 degree. This implies 85 degree plus 60 degree plus Y is equal to 180 degree. Solving the above, we get Y is equal to 35 degree. Now again, DH is parallel to AF and HF is the transversal. Therefore, angle GHE is equal to angle HFA is equal to 95 degree, since they are the corresponding angles on the same side of the transversal. Now consider triangle GHE. We have angle GED is equal to angle GHE plus angle HGE. This we get from the exterior angle theorem. This implies x is equal to 95 degree plus 30 degree, that is equal to 125 degree. Thus we get x is equal to 125 degree and y is equal to 35 degree. This is our solution, which is option number 2. Thank you. Hello, I am Avanti. The question is, in the adjacent figure, triangle PQR is an equilateral triangle. Also, PS is equal to QT is equal to RU. Then, triangle VWX is. In this question, we use the concept of congruent triangles. Consider triangle PQT, triangle QRU and triangle RPS. Now, in the question it is given that QT is equal to RU is equal to PS and PQ is equal to QR is equal to PR, since triangle PQR is equilateral triangle. This implies angle Q is equal to angle R is equal to angle P is equal to 60 degree. Therefore, by the property side angle side, we have triangle PQT is congruent to triangle QRU is congruent to triangle RPS. Now, we know that corresponding parts of congruent triangles are equal. Therefore, we get PT is equal to QU is equal to RS, and let us call this equation number 1. And we also get angle QPT is equal to angle UQR is equal to angle PRS. Let us call this equation number 2. Now take triangles PSV, triangle QTW and triangle XUR. In these triangles we have angle PSR is equal to angle PTQ is equal to angle QUR. Let us call this equation number 3. And PS is equal to QT is equal to RU, which is given in the question. Let us call this equation number 4. Therefore, we get triangle PSV is congruent to triangle QTW is congruent to triangle XUR. Therefore, PV is equal to QW is equal to XR. Call this equation number 5. This we get because these are the corresponding sides of the congruent triangles. Also, we get SV is equal to TW is equal to UX. Let us call this equation number 6. Now, from 1 minus 5 minus 6, we get SR minus SV minus XR is equal to QU minus QW minus XU is equal to PT minus PV minus TW. This implies Vx is equal to Wx is equal to Vw. Since all the sides are equal, therefore triangle VWX is an equilateral triangle. This is our required answer, which is option number 4. Thank you. Hello, I am Avanti. The question is, in the adjacent figure, ABCD is a rectangle. P is the midpoint of DC. If QB is equal to 7 cm, AD is equal to 9 cm and DC is equal to 24 cm, then the value of triangle APQ is. Now the concept that we use to solve this question is Pythagoras theorem. Now since ABCD is a rectangle, therefore AD is equal to BC is equal to 9 cm. This implies QC is equal to QB plus BC, that is equal to 7 plus 9 is equal to 16 centimeters. Also, it is given that AB is equal to DC is equal to 24 centimeters and P is the midpoint of DC. Therefore, DP is equal to PC is equal to 24 upon 2, that is equal to 12 centimeters. Now, we will be able to say that triangle APQ is right angled if AQ square is equal to AP square plus QP square. Okay, now consider triangle ADP. Here angle D is equal to 90 degree. Therefore, by using the Pythagoras theorem, we can write AD square plus DP square is equal to AP square. Putting the values, we get 9 square plus 12 square is equal to AP square. This implies AP square is equal to 225 or AP is equal to 15 centimeters. Next, consider triangle PQC. In triangle PQC, angle C is equal to 90 degree. Again, applying Pythagoras theorem, we get PQ square is equal to PC square plus CQ square, that is equal to 12 square plus 16 square, that is equal to 400. This implies PQ is equal to 20 centimeters. Next, consider triangle ABQ. In triangle ABQ, we have angle B is equal to 90 degree. Therefore, by applying Pythagoras theorem, we get AQ square is equal to AB square plus BQ square. That is equal to 24 square plus 7 square, which comes out to be 625. This implies AQ is equal to 25 centimeters. Now, in triangle APQ, we have AP is equal to 15 centimeters, PQ is equal to 20 centimeters, and AQ is equal to 25 centimeters, which is a Pythagorean triplet. Thus, we get AQ square is equal to AP square plus PQ square. This implies angle APQ is equal to 90 degrees. This is our required answer, which is option number 2. Thank you.